Okay. Good morning. How's everybody? All good in this frigid winter day? Cold? I'd rather have cold than snow. I'm okay with that. As long as there is no snow, no messiness. That's just my opinion, my take. Each one of us, I know that we have our own preferences. Okay, so let's wrap things up for the week today. Our week 6, the topic of our week 6 is actually, it's that one, is this complicated name, this complicated term, polymorphism. Going to be talking about that today. And in a bundle, polymorphism comes together with abstraction, with interfaces, and we're going to be talking about all of them today. This is the last topic for our tests next week. Okay, so this will still be in the test. There will be some exercise that you're going to be able to maybe start today, maybe not, but at least you can take home. And tomorrow I'll be providing the solutions for those exercises. Okay. And then in the last 20 minutes of our class, we're going to go through quiz number 3, which will include 8 questions, 20 minutes, okay? Simple as you are used to. Okay, polymorphism. I cannot raise my table. Okay. So, today we are talking about polymorphism. What is that? Polymorphism, I can tell you, is not a keyword, okay? It's not a keyword that you're going to use in your code. It's just an approach to working. It's one of the key elements of object-oriented programming, okay? It's one of the 3 main key elements of OOP. Now, as part of polymorphism, what we see in C#, we see abstract classes, and we have interfaces as well. Okay? Now, let's break down what polymorphism is. Let's try to analyze these words. Anyone can give me some insights of what the hell is that? Yep. Okay, good start, good start. Just, yes? Yes. Yeah, it's so poly, multiple, many forms. Polymorph forms. Okay, so multiple forms. Multiple forms of what? Well, the same thing behaving in different ways depending on their form. Let's make this a little bit less abstract and more concrete. Let's go through a few examples here. First of all, this content is in the book under chapter 10, so you can have a look there. Okay? So, let's go through a few examples here of polymorphism. We have a bunch of animals here. Each one of those animals, they make some noise, okay? But the way each one makes noise is different from the other one, okay? We could have kids there as well, make noise. My jokes are not sticking today. Yeah, I know, I get it, it's 2 codes, I get it. So yeah, so all of them, they make noise. But, again, it takes different forms. Okay? They are all animals, they make noises, but the implementation of the noise is different from animal to animal. Okay? But they're still all animals, still make noises. Let's have a look at this video here.
bunch of code, a little block of code, and we put in some kind of input. Polymorphism in programming is kind of a different way of thinking. Let's say we have a bunch of code, a little block of code, and we put in some kind of input. And that gives us some kind of output. It does something with the input. Now what if I put in a different kind of input, like I2 here? Is that going to put out some output? Well, no, it isn't, because the code doesn't expect that input different type. So all of this is going to fail miserably. And polymorphism takes care of that. Polymorphism is effectively writing 3 copies of that code, or 4 or 5, just multiple copies of it. And each version of it will take in a different input. So this one will take dog, this one will take cat, and this one will take cow. And they will all output whatever they need. So dog will make you woof, and meow, and moo. So polymorphism is writing the same block of code, and most importantly, giving it the same name, but allowing it to take a slightly different type of argument, variable, or input. And then your program will know, if I give dog to that specific name of thing, so imagine this was called speak, then the program that you're writing knows I have dog, I have speak, I must use this particular bit of code. If I have cat and I have speak, I must use this bit of code. And the same goes for cow, of course. So that is what polymorphism is. We're using one block of code and changing which version of that block of code we're using depending on the inputs that we are giving it.
Yeah, so this is all done without ifs. I'm not checking. I'll give you just 1 second. I will not be checking. If it's a dog, do this. If it's a cat, do that. I'm not checking that. I'm just giving to this code different types of objects. And according to the one that I give, it will call the speak or the make noise corresponding to a dog, corresponding to a cat, corresponding to a cow, whatever it is that the object is being used at that point in time. And you're going to see examples of that. Yes?
What I want to do is I want to present an example to the class. Maybe the Indian guys will understand better.
Okay, perfect. Go ahead.
I have to give the example.
Okay.
Because I read that in a meme in Instagram.
Okay.
So, first of all, we got to understand, all about red label.
About what?
Red label.
Red?
Label.
Red label.
So
Okay. Okay.
Okay.
Okay.
So one is
So maybe you want to explain for the ones that are not familiar with that. What is that?
so it's a whiskey. Red
Okay.
label. So and there is a tea also in India which is named as red label.
Okay.
So let us present that there is father who is more concerned with red label, that's a whiskey, and red label, that's a tea. The mom is concerned about. So there will be 2 classes. First is father, red label, and the mother is red label but the tea. So father will say to the son, go fetch me red label. The son will get whiskey when the father is inheriting that thing, and when the mother will say, go fetch me red label, the mother will get a tea. The son will get tea. So that is the classic example which I saw in in Instagram.
I like that. I really like that. that's very.
Maybe the Indian guy can be more familiar.
That is very good example. I'm gonna borrow that. I'm gonna steal that. I'll be using that example. Okay. I really like that. Yeah. So again, Anyone did not get the example? I think I got it. So that's a good example. Again, you have you can think of, you have get red's label. And if it's a father asking for that, it will behave in one way. If it's a mother asking for that, it will behave in a different way. You got it? It will get the whiskey for the father and the tea for the mother. Yeah? Like that. Love that. Awesome. That's how polymorphism behaves. That's how polymorphism works. Okay? Let's see a few more examples of that. Again, we have different instruments. All instruments, we play those instruments. But the way you play a guitar and a drum set, it's different. Okay? Another example, we have play. Another one here, we have operate. We have different vehicles. Depending on the vehicle, we're going to operate that vehicle in a different way. A truck, we operate a truck in a very different way as compared to a bicycle. Okay? Let's bring this closer to us here. We have a method called satisfy graduation requirements. The requirements to satisfy graduation for high school students, they are different from the requirements to graduate a college student. They are still both students. They still have requirements to graduate, but the behavior of each requirement is different. Makes sense that, again, to graduate a high school student is different from to graduate a college student. The requirements are different, okay? I'd like to play this other video here. The guy has a cold, so be careful not to catch his cold.
Let's say we have an array. Okay, well, let's actually just say for a second we have a class called animal. And let's say we have a class called dog. And dog extends animal. And we have a class called cat, and cat extends animal. And we have a class called turtle, and turtle extends animal. Right? You can see.
So what does he mean by extends? Inherit. Okay? Extend means inherit. Okay? So just another terminology used by him here. Extends, inherits from.
See where this is going. We can have this base animal class, like our base particle class, and lots of subclasses that have all the basic functionality and data of an animal, but with their own customization. Now what we want to do is make an array. In our particle system example, we're going to use array lists, but just for thinking it through right now, let's use a plain old array. We're going to make an animal array called kingdom. Kingdom, which is a new animal array, and we're going to have 1,000 animals in it. Okay? I want to put dogs and cats and turtles into that array. Can I do that? The answer, of course, is yes, otherwise why would we be here? But just think back to, wouldn't that have been your first instinct? Maybe you would have said, I'm making a processing sketch and I have all these different objects on the screen. I need my dog array to keep track of all my dogs. I need my cat array to keep track of all my cats. I need my turtle array to keep track of all my turtles. This is going to get unwieldy pretty fast. In some cases, you might want that, but one of the reasons for doing this inheritance structure is it allows us to kind of collect all of these objects that have the same parents together and work with them together. This is polymorphism.
So I'll just restate what says that. It allows you to get all children classes of these parents and work with them all together, like they are the same kind of bunch, okay? They are different, but they share the same parents. So you're going to work with all of them together. That's the point of what he's talking about. That's the point of polymorphism as well. Let's keep going here.
Polymorphism is going to allow us to put all these different kinds of animals into the same generic array of animal objects. Array of generic animal objects. So let's look at 2 lines of code that I'm going to write out for you here. I'm going to say dog Rover equals new dog. Okay. This is something we should be very comfortable with. We're very comfortable saying, I have an object of type dog, its name is Rover, it's a new dog object. Great. Here is polymorphism, something new that we're allowed to do. Animal spot equals new dog. This is polymorphism. What polymorphism, which means from the Greek, many forms, what it allows us to do is say, I have a dog object. And if it's convenient for me to think of it as a dog object, I'm happy to do so. If it's more convenient for me to think of it as an animal object, that's also allowed. I mean, it really, truly is a dog. A dog is a dog is a dog is a dog. But we can talk about it as if it's an animal, because a dog is an animal. It's a child class. Dog is made from a child class of animal. We can make an animal object which is specifically a dog. This is what allows us to put king.
Now, look at this. You may ask, what's the point of, if I know that I'm creating a dog, I mean, why not just say dog spots? Well, he's just demonstrating the fact that in the array, he's dealing with a collection of animals. On each spot inside the array, it's an animal, which can be a dog, a cat, or in this case here, a turtle as well. So he's just saying that, again, even though the spots in the array, they are all animals, but you can set to a specific animal each one of those spots, and that's what it's going to do with each one. And anyone does not know what an array is. I mean, array is a collection of objects, of items, okay? We're going to be working with collections a little bit later in the course, but in its basic form, array is that, just a collection of array of integers, a collection of integers. Each item in the array has a different, in this case, a different animal.
Kingdom index 0, for example, could be a new dog. Kingdom index 1 could be a new cat. This is the magic of polymorphism. Kingdom is just a bunch of animals. A dog is an animal, a cat is an animal. We can collect all these different kinds of classes into the same array. Great, right? Okay, so hopefully this makes sense to you, but there's one little piece of this that I think would be worth mapping out. What happens when we loop through that array? Right? And we know now, by the way, that we have this new kind of loop that we can do. We can say for every animal A in the kingdom array, I could say, and what do our animals have? They had a sleep function.
He's using a more Java-oriented syntax there. In our case, for C#, it would be something like for each animal A in kingdom. So it would be a slightly different syntax there, but that's the only thing that is Java-specific here, okay?
In the eat function, I could say array. I could say, and what do our animals have? They had a sleep function and an eat function. I could say a.sleep, a.eat. So I could still loop through all of the animals, and when it gets to each one, I don't have to say, if it's a dog, sleep like a dog. If it's a cat, sleep like a cat. That's the magic of polymorphism and inheritance, is it just knows how to do it. It knows, like, we made a dog and put it in the first spot. We made a cat and put it in the first spot. They're both animals, but a dog is a dog is a dog is a dog. When it gets to sleep, it's going to sleep like a dog. When it gets to eat, it's going to eat like a dog. So this is very powerful. We can have an array of generic animals. We can put specific kinds of animals in that array. We can loop through all of them, and we don't have to keep track of which one is which. Java/processing/ the computer, the little people inside the computer pulling in all the switches and buttons in there. It keeps track of all of that for us. This is incredibly powerful. It's going to allow us to make a particle system full.
That's about as far as you need to go, because then you're going to get started on something very specific to what he's doing in other videos. But that's what polymorphism is. It's the ability to work with different classes as they are the same. We are looping through this array of animals, and it doesn't matter if we have a dog, a cat, a turtle. When we call the method, it will do whatever the method of that specific class is supposed to do. Okay. We're going to see examples of that. I have Padlet open in case you want to ask any questions from there. You can also, again, interrupt me at any point to ask me. How is that coming along? I mean, is that making sense? Is that? Okay. Let's have a look at this. So, if I ask you, have you ever created a concrete class? What would you answer? Yep, yes, no, maybe. One class. Have you ever created another type of class? All classes that we have created so far in this course, they are all concrete. Okay? They were all concrete classes. Concrete class is nothing more, nothing less than a class that you can instantiate an object from. You can declare an object and you can say new, like cats. Cats, no, whatever name you want to give, equals to new cats. If you can say new cats, it's because you are able to create an object of that class, and that class is a concrete class. Okay? Now, why am I bringing that? Because that's what you already know. Well, I'm bringing that up because we're going to see a non-concrete class, which is called an abstract class, which is the opposite of a concrete class. An abstract class, you cannot create objects from that class. You can only declare it. You can have other classes inheriting from it, but you cannot create objects from it. Okay? So, you may ask, again, what's the point of an abstract class? That's the point, is to have a collection of properties, of methods that can be inherited by other classes. Okay? Let's start to see a few examples of that. Well, I'm going to flip to the code here. Okay, so in this code, I have demo animals, which is the application. I have the main here, and I'm creating a dog, and I'm creating a cat here. Now, I also have an abstract class called animal. Let's expand that. Look, my abstract class, it has a property, a private field called name. What is this? It's a constructor. So even though this is an abstract class can have concrete methods, concrete members, and abstract members as well. So keep that in mind. I would advise you to write a note about that, because that's a very good question to ask in quizzes. Okay? Graded quizzes. So again, abstract classes can have abstract members and concrete members, non-abstract members, like a constructor like that, or a property like this. We have the definition here, we have the code here, but it can also have an abstract method like this. Well, aside from the fact that we have this keyword called abstract, what else is different from this method as compared to a concrete method? What else do you see there? Or actually, what else you don't see there? No? No return. Let's expand, let's make that a little bit more generic. What we don't have there? It's just a signature, yes. We don't have body, we don't have content, we don't have implementation. We don't have the body, we don't have the curly braces opening and closing. Okay? So that also tells me that, okay, this is an abstract method. There is no implementation. Okay? and it finished the line with a semicolon. So again, it means that we are just saying that animals, they make noise. But let me ask this question. What if I ask you to draw an animal? Can you draw me an animal? What will be your question? What animal, isn't it? So again, animal here is a generic animal. We cannot implement make noise here in this generic animal because we don't know which animal is that one. We don't know. But we can say all animals make some sort of noise. But we cannot define which noise is that one because we are talking about a general animal. An abstract animal. That's why this is an abstract class. We just have conceptual elements in this class. Well, we may have implementation as well, as you can see in the constructor. But again, for this make noise, we just have the promise. We have a promise there that animals, they make some noise. I'm a generic animal. I don't know which noise is that one. But if there is a class that inherits from me, that class will have to make some sort of noise. We'll have to implement that. That's the other aspect here of working with abstract classes. If a class inherits from an abstract class, each and every abstract method of the abstract class needs to be implemented in the child class. Let's have a look at this in a less abstract way. Let's have a look at dog here. So dog is an animal. Look, our animal class has a constructor that has a parameter. So I have to declare a constructor in the child and call that constructor. We talked about that last class, or I think last week. We talked about that last week when we spoke about constructor, or yesterday, I don't know. But we talk about that. Anyway, so we have dog, inherits from animal. Now, look at this. We have make noise, and make noise is implemented here. Let's have a look at a few things. First of all, it has the keyword abstract in the parents. It has the keyword override in the child. Okay? So this override is overwriting whatever. Well, there's no implementation there really, but we have to use this keyword override here in the child. Let's try to get rid of this method here. Do it for a second. 2 seconds. Maybe 3 seconds. Come on, Visual Studio. Help me out here. It should show an arrow right here under dog. Well, if I save this, let's try. Oh, I know. Because this is not... I need to make this my program inside the program class, because right now I just have this file as open, but it's not part of my project. So Visual Studio is not understanding that this is code for this project. So I just have to copy this, put this inside my application. And now we have the problem. So let me go back there and let me Control-Z this. So look, if I move the mouse over, it says, dog does not implement inherited abstract member make noise. Okay, so it does not even allow me to compile the codes because it's saying, hey, you are inherited from animal, animal has an abstract method, and you did not implement that method. You have to. So you can think of abstract classes and methods as a contract. It's a contract that says, if you want to be my child, you have to implement whatever I made abstract. It's a contract. Yep.
Can I use the keyword new or just
Let's try. Let's try. I think you can, but I'm not sure. So I'm going to first delete it, and I think we're going to get a warning here. Yeah, so we just got a warning. I think that we can use keyword new. Yeah, we can. And again, it will behave in a similar way as when we have virtual and override or virtual and new. Override, it will keep the link between them. new will break the link, but it works as, actually, sorry, let me revert that. It does not work because we are here redefining a complete new make noise, actually. So we lost the connection between this and this one here. And again, we still have the complaint here, okay? Does not implement that one. Yeah, so I take it back what I just said, okay? So we're gonna have to use override here. Or as I see a question there, okay, can we have abstract methods in a non-abstract class? That's a great question. I think I paid someone to ask that question. Anyway, no, abstract methods can only be present in abstract classes. I'm going to repeat that. Very good one for quiz as well. Abstract methods can only, abstract members, because abstract can be also property, okay? So abstract members can only be present in abstract classes. However, abstract classes can have non-abstract members, concrete members, like a constructor, like a method as well, okay? Again, all abstract members, they have to belong to abstract classes, okay? Great, so we have dog here, and then we have cat here, and we have make noise for the cat and make noise for the dog. Great. Now, in our main, look at our main there. Look at the main. In main, we have a method called display sound. But look at this. Display sound accepts an animal. Okay? Now, an animal can be a dog or can be a cat. So I can send a dog or a cat to this method, and it will behave. If I send a dog, it will call the dog specific make noise. If I send a cat, it will call the noise specific for the cats. Let's run this. And there we have, okay, the dog and the cat. The message that we called from make noise, it was specific for the specific class, for the dog, for the cat. Okay. Questions? Let it sink a little bit there and see if you have questions. Again, you can think about an abstract class as just the concept. If I say, play a music instrument. Well, we know that a music instrument, it emits sounds, it can be played, they have a price, they have a cost, they have a way to be tuned, but the way to be tuned to tune a guitar is different from the way you tune a piano. So even though they are both instruments, but they have specific implementations of how to clean it, how to tune it, how to play it, okay? Abstract class is a class that, again, it's just a concept. It's a general concept. It's not, you will naturally ask the question, which instrument, which animal, which vehicle? You know, do you know how to drive a vehicle? Well, you may assume which vehicle I'm talking about, but maybe I'm talking about a forklift. Well, it's a vehicle as well of some sort, you know. Okay, so again, abstract classes, they are conceptual. You need a concrete class to inherit from it, to be a child of it. So, oh, you were talking about the cat, or you're talking about the lion here, okay? Let's keep expanding on that. Again, think about the abstract class as the core identity of that class. A dog, a cat, a turtle, a lion, they are all, at their core, they are animals. They are all animals. So the abstract class is defining the core of that object, of the child object. Different music instruments, they are all instruments. A few different examples here. We have artists. and we have specific types of artists, like a singer, an actor. Those are different types of artists. Sculptor, painter.
So here, sculptor,
Yep.
painter, and illustrator, they are abstract classes, right?
No, they are not. The abstract is artist here. Artist can be any kind of artist. We can have a singer, we can have a dancer, we can have a sculptor, we can have a painter, we can have an illustrator. So those are concrete classes. So with the pointy white triangle pointing to the parents, it means that we have a relationship between parent and child.
So the artist class here,
Yep.
Does it have any parent?
Well, answer me that. Does it? Objects. All of them, they have object as the parents. Even if it's not here, but implicitly, their topmost parents is objects. Okay?
I know that normally in the concrete class, for the field is private, but in here it seems like it's all public.
Yeah, but those are not fields. Those are properties. Remember, fields, they have lowercase in the first letter. But again, this is just a rough diagram. But those are properties, not fields. Okay? So you can think about them as auto-implemented properties, because there's no fields listed here.
So where did you declare all the fields?
Well, the same way as you declare with a regular class. The same way. Because as I said, an abstract class can have concrete stuff. Concrete stuff similar to regular classes. You declare as you declare in a regular class.
So in the inheritance,
Yep.
abstract class is always parent. Is that true?
Well, I can tell you this. If an abstract class does not have children, it cannot create objects. So it doesn't serve too much of a purpose to have an abstract class that has no children, because again, it died right there. We cannot do much with that one. We cannot instantiate an object from an abstract class. We can declare. Here's the thing. We can declare, like I can declare an animal, but I cannot say new animal. I have to say new dog, new cat. Okay? So again, if we just have the abstract class, it's not doing much for us. Okay? Yes.
We cannot create the object from the artist now.
Yes, we cannot. Correct. Okay, good question here. So can an abstract class inherit from another abstract class? Yes. Yes, it can. Okay? Okay. Okay, again, animal, we have seen this example before. We have gone through the example of that. Okay, again, this is the example that we have gone through. Again, we know that we have to use the keyword overrides when we are overriding the abstract methods. Okay, before we get to interfaces, what I would like to do is this. I would like you to check what interface is. So if you go to Centennial, under week 6, you're going to see a few links here about interfaces. Okay? So the link about interface, check that out. Have a look at that. I'd like you to get to know it a little bit before I give my spiel here about it, okay? So have 10 minutes to have a read at that interface, and we get back when we keep moving forwards. 10 minutes for this one here. So again, in Centennial, week 6, 2 links here about interface. You can even copy the codes and test the codes with Visual Studio. There is some codes sample on those links. And you can even see also the difference between abstract classes and interfaces. Yep.
Some questions regarding my assignment.
Okay.
So for employees, CS, I actually added a thing called ID counter. Is that allowed? Or?
Okay. Okay. You are getting the ID automatically, correct?
Yeah.
That's fine. That's fine. It's a strategy that you decided to use. That's fine. That's okay.
Yeah. And should I write my constraints within my employee.cs?
The constraints that you mean, you're talking about the range that, to validate?
Yeah, it cannot be more than 0.
Yeah, so here's the thing. We are collecting that from the main program, correct?
Yep.
So I would say that ideally, you can have validation here, but ideally, you're asking this question not here inside the fields. You are asking this question in the interface there in the program. So leave it here. Don't ask the question. Actually, don't ask the question here. Ask the question there in the program.
No, it's not asking the question. It's just if the person enters a value below 0, just says y is cannot be.
Got it. But are you asking again? Or you are? Yeah. So what I would recommend is that keep the class very clean. Don't ask questions here. Don't collect.
So I do the please enter value in the main.
Everything. The read as well. The reads. So you present data and you collect data in the main. So here inside the class, don't interact with the console inside the class. Okay. Leave the interaction with the console outside to the program.
So it's over here.
Yes.
Right.
Okay. All the validation, keep it here. Keep that loop. That's great. Keep it here. Okay.
In here, so move the loop from here to
yes.
here. Right,
yes.
got it. Thanks.
Okay. Let's keep the class very clean without the need to interact with the console. Okay.
And just also a question: are you fine with magic numbers or something? I set all the defaults over here.
That's okay. That's fine. Okay, let me see here. Yeah, that's okay.
Because I heard from
that's
my
fine.
friend for what he did, he actually made constants.
That's to be quite honest, for this kind of example here, I'm fine either way.
Right.
Okay.
Thank you.
So yesterday we submitted the assignment, but I'm in another section. Do I need to get into a solo group?
No. You can leave it. You're just gonna, once I release the grades, you just have to come to me and remind me, oh, I'm from the section, I'm with the group from section so-and-so, group number so-and-so. Because then I can apply the same grade to you, okay? Okay, I'm gonna take a quick attendance here. Ahmad? Amanpreet? Anu? Brandon? Kai? Dani Fu? Dani? Fábio? Jayton? Jay? Chang Sao, John Avenido, Luana, Lufu, Manpreet, Marvin, Mehmet, Mukahit, Raul, Ravi, Ricky, Ritesh, Salim, Sampath, Sanchit, Smurith, Steven, where is Steven? Tanjinder, Theory Kind, okay. Tomoki, Vin, Wahida, Inyu, Eugene, Zangir, I put it. I added it. Okay, so take 5 minutes break, and when we come back, we keep moving forward. Hopefully you had a chance to look a little bit at the interface, but again, we get started in 5 minutes. What's up?
Can you share this code at the bicentennial?
What is that?
Just today's code.
If it's in Centennial, yeah, it is. Let me show you there. It's under coding figures. Okay.
This today abstract classes?
Not for the exercise. The codes that I have been showing. Yes, it's right there. Yep.
So I'm running onto other problems.
What is that?
Once I close my folder and when I open my program again, like everything just turns white and the console command doesn't work anymore. So basically, for example, if I try to do the console, it's not there anymore.
Okay, get rid of that line and compile. Try to compile. Yeah, try to compile. Go to build. Rebuild solution. Rebuild.
That's not supported.
I mean, you are doing .NET Core.
Oh, .NET. Oh, some substitute framework, right?
Yeah, you need to adjust that. Okay. Okay. So let's get going. Dinner is ready. Okay. So, who had a chance to read a little bit about interface and can tell me something about interface? It doesn't need to be the whole definition, but just something that you understood about interface or something that you found that it's hard about interface. I don't know. Anything. Give me some reaction there. Anybody? Say it again.
We can define the matrix in the parent class and can declare the matrix in the parent class and actually write the matrix in the child.
Okay. So you define the parent class, and then you use the child class. You define what in the parent class? The inheritance, the interface. Okay. Let's keep going here. Let's keep moving forward. Anybody else? Any other opinions? Okay. So you can have a class inheriting from an interface, and some other class inheriting from that class. Okay, you can have that. Let's keep going. Let's see if anybody else has any other opinions. Yes?
Same like abstract class, but it only contains the methods.
The contains?
Methods and only abstract methods.
Okay, that's correct. It's similar to abstract classes, but only contains abstract members in general. Methods, properties, if we have properties there. Okay, so every single member in an interface, they are all abstract. Okay? Anything else comes to mind? What about multiple inheritance? So, C# has multiple inheritance or not?
No.
Some people may have different opinions about that because here, why is that a topic that, some people say one thing, some people say something else? Can a class inherit from multiple classes? Can one class inherit from more than one class? No. It doesn't matter if it's an abstract class, if it's a concrete class. A class can only inherit from one other class. However, what about interface? I can have a class inheriting from multiple interfaces. But interfaces are not classes, really. They are not classes. They are, well, interfaces.
They behave like a parent class?
It's like a parent, but I'll try to explain that a little bit better with a few examples. Actually, this is I like this definition. Interface is used to implement peripheral abilities of class. What is peripheral? Anyone can tell me what is that? Around it. It's not the core. Abstract class, it means that it's the core of a class. Interfaces, they are add-ons. You can think about plugins, add-ons. It's, let's add this extra feature to the class. It's just extra stuff. It's not the core of the class. And here's why. I'm going to demonstrate that with some examples here. We have here an interface. Well, this is how an interface looks like. It has an accessibility modifier, it has a keyword interface, and it's called iWorkable. Well, can you give me an example of a child from iWorkable? Now, if I ask you, can you give me an example of a child of an animal? The answer comes right away. A child of an instrument, a music instrument, I'm sure that the answer comes right away. A child from a vehicle, the answer comes right away. So, animal, instrument, vehicle, those are all abstract classes, but they represent the core of what their children is. The core, you know what is a music instrument, you know what is an animal, you know how a vehicle looks like, but iWorkable? What the hell is that? There's no clear child of iWorkable. Who's the children of iWorkable? Well, you know what? iWorkable, the children can be an employee, can be an animal. Employee does some sort of work. A student does some sort of work as well. An animal does some sort of work. So again, you can think about interfaces as add-ons, as nice to have features for those classes, but they are not the core. They are, well, let's see here. They are peripheral abilities. They are just abilities, okay? But they don't define the core of what that class does. Let's have a look at this example with iWorkable. So iWorkable has one method. Now, look at this. Even though it is an abstract method, because there's no body, no implementation, however, we don't have the keywords abstract. Okay? No keyword abstract. Inside interfaces, you don't add the keywords abstract. You don't need to, because everything inside an interface, everything is abstract. There is no concrete implementation whatsoever at all. Okay?
You can?
You cannot.
So abstract adding, if we want to add, is it possible to add?
The keyword abstract? No.
No?
It won't compile. So again, it is an abstract method, but there's no abstract keywords added to the definition. Because every single member inside an interface, they are all abstract. So again, if I ask this question, can an interface have a concrete method? No, it cannot. Okay? No concrete members inside interfaces. What is similar to an abstract class is that I can aggregate all classes that have iWorkable together because they share one single parent. Okay? Let's have a look at the example here. In the next slides, look at this. Look, we have employee, we have animal, both inheriting from iWorkable. Again, if you think about that, I mean, what is the common elements of an employee and an animal? Not much. Okay? But now you can have them sharing the same. Actually, you can have, the correct terminology would be, you can have them implementing the same interface. They are inheriting from iWorkable, which means every abstract, which is all, every single method of iWorkable, it needs to be implemented by whoever is inheriting from it. The same way as we had abstract class, abstract methods, the children must implement that. For interfaces, the children also must implement each and every single abstract method there. So that's why we have employee, and we have here, look, public string work. If I get rid of this, it won't compile, because it will say, hey, you said that you want to inherit from iWorkable, but you are not implementing work. That's not possible. So we have now, look, we don't need the keyword override here either. So again, interface behaves, it's similar to abstract classes, but they behave slightly different. I don't need the keywords override here because we know that in the parents, in the iWorkable interface, there is no body there. So it has to recreate that anyway, okay? Great, so here animal. Well, we can have an abstract class inheriting from an interface. That's fine. Look here. The work method has been declared as abstract here. So in my abstract class, which is inherited from iWorkable, it's not really defining work. It's just saying, hey, I know iWorkable. I know that you want me to implement work, but hey, I'm an abstract class. So I'm gonna make this work abstract as well, and I'm gonna let my children be the ones that are truly implementing work, which we have dog implementing work here. I watch the house, and cat catching, I think, the mouse, something like that. Okay? Now, here is the caveat, is that classes can inherit from multiple interfaces. I can say, let's just assume for a second that animal is not inheriting from iWorkable, okay? It's not. So I could say dog inherits from animal, comma, iWorkable. So I can say that. It can only inherit from one class, but it can inherit from as many interfaces as it wants. Okay? Again, I'm going to say this again. Classes can only inherit from one single class, no matter if the class is abstract or concrete. However, it can inherit from as many interfaces as you want. That's why we say that C# simulates multiple inheritance by doing that. It's not true multiple inheritance, but that's kind of the way it's work around that. Okay? Okay, let's see if there are any questions there. Okay. Let me give you another example here. Just a quick one. Look at this. Let's talk about musical instruments. Okay? We have a class, a general application class here. Actually, it's not even implemented. Let's look at our abstract class. Look, we have instruments. We have play method, which is abstract. But we have, look at this. We have this interface called iSellable. Well, iSellable, it's an interface that is used to share selling this sale methods. It's abstract, of course, because every single method in an interface is abstract. But now, what is it that I can sell? I can sell musical instruments. I can sell animals as well. I may have a pet shop, a pet store. So again, I can apply iSellable to very different types of classes. Classes that don't have anything to do with each other. There's nothing to do, a musical instrument with an animal. But they can inherit from iSellable. Because I may have this, as this example has, a way to sell a product, and I can sell a musical instrument, I can sell an animal as well. Okay? So again, it doesn't define the class, it's just, we're just adding the ability to make a sale for the instrument, the ability to make a sale for the animal. So how do we implement that? Well, I can say instrument inherits from iSellable, and then in my instrument I can say, okay, given the price, the instrument costs this amount of dollars. Okay? And again, now in guitar, again, we can do the classical inheritance here. Okay? But this is how we use interfaces. Yes?
Can you give us, in this example, can you add one more interface and see how that works?
Yep, we can. We can just, let's think about another interface here for a second. So let's think about something else. For the music instruments, yeah, let's think about non-perishable. For musical instruments? Okay, it could be. Again, I could think that yeah, it could apply to pet shop as well. So so let's say that it could return a true or false. It could be something that is perishable or is not perishable, something like that. Yep. Okay. Okay. So actually that brings me to a good point. That is about terminology here. Okay, and then I can say is perishable. What is that?
You forget the
No, that's okay. That's okay. I think it's okay. Okay, so now look at this. Instead of creating a method, I'm creating what here? A property, okay? So instead of having a method, I could have created as a method, but I can create as a property as well, okay? So now what I can do is, I can inherit this right here. I can just say that. Now, I have to implement this. I'm not going to do that right now, but I would have to implement it here so, again, it doesn't complain about that anymore. But that's how you can do multiple inheritance with more than one interface. Okay? Yes?
Can we inherit one class and one interface?
One, like this?
Like for
Yes. Actually, here's the thing. Let's say that we don't use perishable in the instrument. We use it in the guitar. So we can say like this. That's okay. Okay? Now again, it's complaining because I did not implement the property, okay? But and again, we keep saying comma, adding more interfaces here, okay? Now, I just want to mention about terminology. This is important, okay? So, to name interfaces, we have to start with capital I. The second word starts with capital letter, and then usually it ends with able. So I workable, I sellable, I perishable. And again, you can try to squeeze an able anywhere you can. Not so much mandatory to have this able, but usually that's how we try to fit that, okay? But again, at the beginning, keep it an I to indicate that it's an interface, and keep the next letter being capital, okay?
It's a must or
it's a must. It's a must. Let's make it a must, okay? A must, you know what that means, okay? Okay, what else we have here? Okay, let's take 5 minutes and do a little different exercise here. And then we're going to go through our quiz. Let me show you this kind of puzzle. It's kind of a puzzle. I'm going to demonstrate that in one example. And I'm going to give 4 to you to work it out. If it loads. Okay, so the idea is that on the left-hand side, you find this code that is mixed up, okay? Now we're going to drag each element, each block to the other side and put this in order. Now, keep in mind that there is one element here that is called a distractor. It's wrong. You should not put it there. So it's up to you to organize this. So I'm going to give this example here. This seems to be a class. So I'm going to drag there, class, and I'm going to open curly braces here, and then there's a constructor. Which one is the constructor? The last one, or the second one? The last one. Okay, so I'm going to say something like this. It's important to use indentation as well, just to make it fully correct. And then I'm going to open curly braces here. I'm going to say write console. I'm going to close it here. And I'm just going to close it here. I'm going to do something wrong here. Let me just put it here as well. So I can click on get feedback. It will tell me what's going on wrong. I can click OK, and it will tell me where the problem is. And I can just fix that by dragging it over. If I mix something up here, it will tell me that there's a problem as well. It shows me where the problem is, so I can just rearrange and fix that, get feedback, and here we go. So I'm going to give you 4 of those. They are related to abstract classes, to interfaces. Try to work them out on your own there. We have 5 minutes for that. And I'll be walking around to see if anyone needs any help there. I'm going to post 4 links on Padlet for each one of the problems. So we have Padlet here. So I'm going to call puzzles. And we have 4 there. Give it a try, 5 minutes. Okay, after this, we're going to move to the quiz.
After this, we have to go to
What after this? No, after that you can just leave it and go to the second one. When you get everything green, it means that you did fine, so you can leave to the next one. So,
It's not related to this.
okay.
I was trying to do these exercises yesterday, and I got stuck here, because I know how to put all the details into the file.
Yep.
But suppose the user says he wants to process 3 orders.
Yep.
So how do I do the 3 objects, or do I just use a single object and do it?
You're gonna do just in a loop. You can use a for I equals to 0 to 2 or 1 to 3, and then you're gonna ask the questions in a loop and again, and then at the end you write right line, right line, right line. So after each loop it writes, and then outside the loop you're gonna close the file at the button, and outside before the loop you're gonna open the file.
Yes.
So you open, ask, and write, and then close them.
Yeah, that's what I was confused about. If I had to loop or ask the user for number of orders and then create that many number of objects.
Well, I'll leave it up to you, but the way to create that number of objects, it's via loop. There's no other way that you can create. You can create, let's say, dynamically. 3 or 10 or 100. How am I going to create 100 orders here?
Yeah.
Okay, so loop.
Okay.
Okay? Be there in a second. So,
This is my thought.
yep.
The reason why we cannot use public is because this is a property, and secondly is already being deployed, and everything inside the interface is public. So that's why we cannot use.
Actually, not really. Actually, here's the thing. So the interface itself can be public. Now, the properties inside, it's not up to the interface to define if it's supposed to be public or private. Just imagine this. Does it make sense to have private methods in an interface? What's the point? Because then
you cannot inherit.
you cannot even do anything with that. So again, we don't have access modifiers inside interfaces at all. Public, no, it's none.
And
Not private, nor protected, no, none of that. Yes, I'll put.
With interface class,
Yep.
we cannot have a public
Don't call it interface class. With interfaces, because they are not classes.
interface.
Yes.
We cannot have any public methods.
We cannot have the access modifier. It doesn't matter if it's public, private, protected. You cannot, not at all. Just imagine, I mean, what would be the point of having a private member? Private only means that you can only access. So again, private, public, and protected, they are for the classes to define. You don't define that inside interfaces.
How about the abstract?
Yes, you can define that.
Can I have a public in the abstract?
You can.
But I cannot create an object from that. What's the point of that?
For the inherited classes.
So protected is enough for them.
I would have to investigate that. I'm not sure if protected. No, protected will not be enough because protected is only for the children, not for the outside. If I want a property to be accessible from the outside, I need to make it public.
But the thing is that we cannot create an object from that abstract class.
Yeah, but the children can. And the children may want to expose that to the outside world. Okay? I just have to get the... So you took the quiz already?
Yeah.
Okay, so let's keep moving forward. Hopefully you have been able to do the little puzzle there. Hopefully it helps a little bit in terms of how to use, what is the syntax of interfaces of abstract classes. Now let's jump to our final segment here, our quiz. Should be already available under Centennial. So 8 questions, you have 20 minutes. And can you please confirm that you can see quiz 3 right now? Just refresh the page of quizzes, and you should be able to see quiz number 3 over there. Again, open book, open web, open Visual Studio, not open Friends. Okay? Can anyone confirm that you can see? Yep.